start things off, I have a question for you. How many of you went to the public schools? 1, 2. Okay, I'm going to show you two pictures and tell me which one best represents your typical learning experience in the public school. A or B? A or B? A? Any B's? No B's? Who is this over here? Ooh, yes. Okay, of course, for some of you, your typical learning experience in the public school will look more like that. Okay, what about how did you learn science and history in school? A or B? A. A lot of A's. Now, I asked my mom this question. She said when she was in school, she did a lot of memorizing for tests. She memorized things like the table of elements with their abbreviations. What is the second law of thermodynamics? What does Australopithecus mean? Imports and exports of Bolivia. And when was the Louisiana Purchase? These are the kind of questions she had to memorize. So I asked her a question. Mom, when was the Louisiana Purchase? And of course, she didn't actually know when it was. Here's an example of that. When did the Pilgrims land at Plymouth Rock? It's a test question. 1620. As you can see, I've memorized this utterly useless fact long enough to pass the test question. I now intend to forget it forever. You've taught me nothing except how to cynically manipulate the system. Congratulations. They say that satisfaction of teaching makes up for the lousy pay. Okay, so think about what do you really remember from school? That is, what left a lasting impression on you in a positive way? If you're like me, you probably remember the projects you did. When we were young, we did a lot of projects. Here's a picture of my brother and one of his science fair projects. Here's his project. Here's my brother. Here's the judge. Here's some of the projects we did here. Then there was history fairs. Do you have history fairs around here? Yes. Yes, where people study a topic. This is the way we did it. Study a topic and then have one of those three-sided boards, and everybody shows up in some sort of a costume or something. And everybody looks at each other's boards and criticizes them. Here's some of the history projects we did. Then there were endless essays. My mom made me do a lot of essays. Here's a picture of me doing my essays. But I would say when we did a project, we learned a lot. And I would say what we learned stuck in our heads and is more useful today than when we memorized. So why do we remember the stuff we learn in projects? For one thing, it's a lot more fun than memorizing things for a test question. Also, we know how the information we're getting is useful. It gives us a place to put our facts. Also, we have a goal for what makes a project is that we're trying to accomplish something. We're trying to win some money or build something, and we're doing whatever it takes to get it done. But the point we're going to bring out here is that projects will use your brain. Here's a picture of your average 13-year-old brain. It looks something like that. And when he's memorizing, he's going to be using a very small section of the brain way back there. But when he does a project, he's going to be using his entire brain. Projects develop the different parts of the brain that contain creativity. Creativity is located up here in the circumferential lobe of the brain. And when he does a project, he's going to have to come up with an idea for it, and there's going to be a lot of creativity involved. Another part of the brain is the decision-making part of the brain, called the decidal lobe. And when your child does a project, he's going to have to make some decisions about what the project is going to be and all kinds of things like that. Another part of the brain is the discipline section of the brain. This is called the back 40 lobe. By the way, don't write this stuff down. And when he does a project, he's going to be have to do some discipline. Another section of the brain is the critical thinking section called the thinkal lobe. is located near the top. And when he does a project, we're going to be talking about this more later, he's going to need some critical thinking skills. But the mainal lobe of the brain, the largest section, is located near the center and is the fun section. And when he does a project, it'll be a whole lot more fun. So my point here is that when a child does a project, before he does the project, he will look something like this. Maybe he'll be smiling and his hair will look like that. But after he's done with the project, his head will be significantly larger and his hair will stand out on end.
Okay, we're going to be talking about opposing viewpoints here as a thinking skill. Here's a cartoon to illustrate that.
I need some help with my homework, Hobbs. What's the assignment? I'm supposed to write a paper that presents both sides of an issue and then defends one of the arguments. What's your issue? That's the problem. I can't think of anything to argue. That's hard to believe. I'm always right and everybody else is always wrong. What's to argue about?
Okay, in this cartoon, what's Calvin's problem? What's the problem he's having? He can't think of, an opposing viewpoint, a side that disagrees with him. So I wanted to find two sides of a non-controversial issue that wouldn't start an argument or anything like that. So I chose the Civil War. We're in Wisconsin, this should be safe. Let's pretend you want to study the U.S. Civil War, okay? How would we study the U.S. Civil War? How would we start studying it? Well, first of all, most people they already know something about the Civil War from history books. And for instance, we know there was this battle at Gettysburg and the North won. And Lincoln was president, and he was a really nice guy. And we fought to free the slaves. The South started it, by firing on Fort Sumter. And Lincoln was assassinated because of what he stood for. We could even read the story of the little girl who wrote a letter to Lincoln about how he needed to grow a beard, and here we have before and after photos. It's a very cute story. We live in Illinois, of course, and that's the land of Lincoln, and so we can go around looking at statues of Lincoln all over the place. We could take field trips to the Underground Railroad. We could even read Uncle Tom's Cabin about how the South treated their slaves badly. Okay, question. Is this what the history books say, basically? Something like this. You read a history book, and this is basically what it would say about the Civil War. Yeah. Most of them would. Have you ever wondered if there maybe is another side of the issue? Of course, this is a homeschool audience, so everyone knows there are other sides to the issue, but like this guy. Let's pretend like we were from Alabama and we wanted to study the U.S. Civil War. How would we start? Alabama, way down in the south here. Southerners grow up hearing a different kind of story about the Civil War, different things about it than we hear up north. For instance, they have baggage, just like we do. If you're from Alabama, for instance, you call the Civil War the war between the states. Or you could call it the late unpleasantness. Or you could call it the war of northern aggression. These are things Southerners call this, the war, sometimes. If you want to study, an Alabama person might look for a biography of Robert E. Lee that told us about how he fought for freedom and was against slavery, which is true. We might even read The South Was Right.
Which is quite obvious what viewpoint it takes.
And in this book, you'll read about how many slaves loved their masters. Slaves fought on the side of the South. And many Southerners were against slavery, but fought for Southern independence. All things that are true. We might even read this book, The Real Lincoln, and the story about how Lincoln was crude and rude and spat tobacco on the White House carpet. Okay, can you see why there's 2 points of view in the Civil War? Obviously, there was 2 sides in the geographically.
And the
they still
North
exist.
won.
Yeah, the North won. Are either of these sides, as I presented them here, balanced? No. Is it healthy to only look at one side of an issue? No.
Calvin and Hobbes. My powerful brain has come up with a topic for my paper. I'll write about the debate over tyrannosaurs. Were they fearsome predators or disgusting scavengers? Which side will you defend? Oh, I believe they were fearsome predators, definitely. They're so much cooler that way.
We could call this fallacy the avoiding opposing viewpoints fallacy, where you're basically avoiding, you're not looking at the other side.
My paper is entitled Tyrannosaurus Rex, Fearsome Predator or Loathsome Scavenger. I say Tyrannosaurs were predators because it would be so bogus if they just ate things that were already dead. I'm a concise writer, okay?
How do we study opposing viewpoints? If we recognize that they're important, how do we study them? How do we go about consciously, we're going to study this as an opposing viewpoint, this issue as an opposing viewpoint? How would we do that? Well, first of all, there are always positive and negative aspects to every viewpoint. Any viewpoint out there, there's positive and negative aspects to that viewpoint. And it can be hard to look at both sides objectively. To illustrate that, I chose, and we're going to use what's called an opposing viewpoints chart. This is where you put one side of an issue on one side of the piece of paper, and the other side, on the other side, draw a line down the middle, and you start listing things. What's something on this side? What's something on this side?
You don't necessarily have to agree with what you write down.
Yeah. You have to agree, but you have to think of reasons on this side and reasons on this side. And we chose homeschooling is good and homeschooling is bad. Okay, so what's a reason for why homeschooling is good? What's something we could put over here? We're talking to a homeschool audience, so I'm sure you should be able to come up with something. It's biblical, okay? Well, one thing we put down is higher test scores. People immediately think a lot of homeschoolers have higher test scores.
What would be over here?
You can move at your own pace. That's something you put over there, yeah. It's inexpensive. Less bad peer pressure. Parents can pass on their values. That's a biblical thing. Okay, what's something we can put over here? Homeschooling is bad.
Socialization, yes.
No snow days, which is true. Lower family income. Generally speaking, homeschooling families only have one family income. Less accountability. That is a concern of people who don't homeschool and disagree with it. These are reasons. Remember, we may not disagree with these reasons, but these are reasons you need to put down on this side.
Or they might not be very important reasons, but they're
could hide abuse. Some people are concerned about that. Homeschoolers could hide abuse. Now, this chart, looking at things this way and creating opposing viewpoints charts on different issues, is a very useful tool for studying many different issues.
Okay. We're going to play History Detective again. Does anybody know who that is again? Oh, okay. Just checking. Studying history from the angle of opposing viewpoints is a lot like being a detective because we don't actually know what happened in the past because we weren't there. We just have clues as to what happened. So we're going to study a specific issue. This is called the gunfight at the OK Corral. How many of you have heard of the gunfight at the OK Corral? Okay, everybody has heard of it. This is the epic confrontation between the Clantons and McLowrys, who are over here, and the Earps and Doc Holliday over here, and the horses were just kind of in the middle. Here's an overhead view of the gunfight. It actually wasn't the gunfight at the OK Corral. It was the gunfight off of Fremont Street between Fly's Rooming House and the Hardwood House. Nobody wanted to call it that, so they just call it the OK Corral. And actually, the gunfight took place, it was over in like 45 seconds, and there was a lot of shots fired, and they were very close, like from here to him. And a lot of shots missed, too. They weren't very good shots. So that's an overhead view of it. Okay, here's a cartoon. Let's see here. Oh, close but no cigar. You want the place up the road, same as I told those other fellas. It says, okie dokie corral. Okay, if we wanted to find out about the gunfight at the OK Corral, we could look at many different sources for the gunfight. We have movies we could watch. Here's Burt Lancaster and Kirk Douglas. There's books written on the topic, history books, newspaper articles over here, photographs, eyewitness accounts. That's wider up there. But if we read these sources, they're going to be telling us different stories for what happened, because it is actually a controversial topic. It isn't like what we were all taught, that Wyatt Earp was the perfect person. We have two sides to the gunfight of the OK Corral. We have the Earp side. They say the Clantons started it. This is their story. They say, we were trying to disarm the Clantons when they shot at us. We only fired in self-defense. That's what they say. And over here, this guy's Ike Clanton. He's actually the only guy on that side who survived the gunfight. Everybody else was killed on that side. And he says, we tried to surrender, but weren't given a chance. The Earps just started shooting. So let's look at one source for the gunfight at the OK Corral and evaluate it. History of the American West by historian A. That's not his name, I just put A there. Published in 1995. Okay, this is what he says. The traditional view of the gunfight at the OK Corral, which says the Earps only shot in self-defense, is far from the truth. In reality, at the beginning of the fight, when Virgil Earp told the Clantons and McLowrys to throw up your hands, the cowboys obeyed. Then the Earps shot them down in cold blood. Okay, so which side does that take? The Clanton side. It's very firmly on the Clanton side. But the question is, should we believe historian A when he tells us something? Reasons yes and reasons no. What are some reasons yes? He's a historian. Yes, that's a very good point. History book, and history books usually have some sort of standard for what goes in there. What are some reasons against historian A? Here's one reason. Historian A doesn't cite his sources. He doesn't tell us why he thinks this. He just says it. What are some other reasons why we shouldn't believe historian A? What about this? Historian A is not a primary source. So what do I mean by a primary source? A primary source is an eyewitness, somebody who was there and actually saw the events in question. For the history detective, primary sources are desirable because they are a direct connection to the events. Primary sources for the gunfight would be the Earp brothers, Doc Holliday, Ike Clanton, the horse, and any other bystander who happened to be there. So is historian A primary source? No, it says published in 1995. You'd have to be really, really old. Generally, history textbooks aren't primary sources. And if we really wanted to find out what happened, we would have to go to a primary source. So let's read what Wyatt Earp says about the gunfight at the OK Corral. Wyatt Earp. The McLowrys and Clantons sent us word that if we did not come down there and fight, they would waylay and kill us. So we started down after them. Doc Holliday, Virgil, Morgan, and I. As we came to the lot, they moved back and backed against one of the buildings. I'm going to arrest you boys, said Virgil. For answer, their six-shooters began to spit. Frank McLowry fired at me and Billy Clanton at Morgan. Both missed. I had a gun in my overcoat pocket, and I jerked it out at Frank McLowry, hitting him in the stomach. Ooh, we got some bullets coming through here. Okay, so which side does Wyatt Earp take? Duh. Obviously, he takes his own side. So, should we believe Wyatt Earp when he says something? Is he a primary source? Oh, yes, we know he's a primary source. He's actually a very good primary source because he was there. He was right there. And anybody who was like down the street a ways and kind of saw it, they might have not have seen it very carefully or clearly like he would have seen it. Actually, yeah, he's close to the action, okay. Another reason is Wyatt Earp is a peace officer, so he has a reputation, not like just anybody who happened to be there. So what could be some other reasons why we should believe Wyatt? Can you think of anything? I can't think of anything. What are some reasons why we shouldn't believe Wyatt Earp? Biased. That's a very good point, yes. Wyatt has a reason to lie. So what do I mean by a reason to lie? Someone has a reason to lie when he says things that would make him look good or help his interests. Here's an example of a reason to lie. Dilbert cartoon. If you hire me, I'll work 100 hours a week and never ask for a raise. I went to a school at a top secret facility for super geniuses. That's why it's not on my resume. And I'm sure it's all true because he says he's honest. Apparently, it doesn't take one to know one. Okay, so why does he have a reason to lie? Because he wants to get the job as just whoever he is, prospective employee. So can you think of any reason for Wyatt Earp to lie? Why is he biased? He killed somebody, so obviously he might be going on trial. And he was actually on trial for murder like a couple days after that. He was acquitted. And he had a very good reason to make it look like it was self-defense. So what do we do when someone has a reason to lie? We know they have a reason to lie, but we don't actually know that they're lying. What do we do? And we need to verify what they say. We need to look for another piece of evidence or some testimony that supports what they say. We can't just rely on them. We have to look for somebody else, too. So let's look at another bystander. John P. Gray, bystander. Let's see if he verifies what Wyatt Earp says. Here's a picture of John P. Gray. The three Earps, Wyatt, Virgil, and Morgan, and Doc Holliday had stepped suddenly out onto Fremont Street from the rear entrance of the OK stable lot and immediately commenced firing on the cowboys who were preparing to leave town. It was over almost as soon as begun. The Earps called out, "Hands up," and began firing almost simultaneously. Okay, so which side does this take? Does it verify Wyatt Earp? No, it doesn't. Actually, why does John P. Gray's testimony strongly support the Clanton side? Why is it a good reason to say the Clantons were right? It's what?
Eyewitness.
He is an eyewitness, yes, but what's another reason that strongly puts him on that side? He doesn't, as far as we know, he doesn't have any reason to lie, because he's just a bystander as far as we know. So that's a strong reason to put him over there. Of course, if you really study the issue, you might find out that everybody pretty much in the town had a strong side on the whole issue. So nobody was completely without bias anyway. But let's sum things up about the gunfight here. Here is my humble opinion on the topic. Here we have the pictures of the people who survived the gunfight. Here we have, that's Doc Holliday, it's Wyatt Earp, this is Virgil Earp, he was the oldest. This guy was the youngest. He was Morgan Earp. He actually died like a few days after the gunfight. The people who were on his side kind of ganged up and they shot him. So it was kind of a mess. And this is Ike Earp. Ike Earp, yeah, I think so. And in my opinion, these are actually the only people who really knew what happened in the gunfight because they were actually there. And it was over so quickly. Anybody who was down the street couldn't have noticed it. There was such a small amount of time between the Earp saying, "We're going to arrest you," and then the shooting starting, that nobody could really tell. So, in my opinion, these are the only people who know, and they're so biased that you can't really tell. So, sorry, there's no real conclusion to it. But the point is here, dude, did you know you were doing logic? We learned here, hopefully, that studying history requires some critical thinking skills, and that primary sources are better than secondary sources. And also, we learned that when someone has a reason to lie, we need to verify what they say.
Okay, we've been talking about history and opposing viewpoints, and now we're going to talk about a little bit about science, and specifically talk about, does a possibly make a probably? We can commit fallacies when we do science. Fallacies are mistakes in our thinking. We call one of these fallacies the possibility fallacy. We made up this name. This is a new name. Breaking news. This is when we confuse a possibility with a probability. And I'm going to explain about how this happens. Here's a possibility fallacy that Calvin is committing.
Life is full of possibilities. For example, right now, instead of waiting for the school bus, I could stick out my thumb, hitch a ride, and spend the rest of my life in the Serengeti migrating with the wildebeests. The Serengeti is in Africa. You couldn't really hitch a ride there. Life is full of precluded possibilities.
Here you have Calvin is confusing what is possible with what is probable. It's possible he could get to Africa by hitching a ride. It's possible, but it's not probable. It's more probable his mom is going to catch him. Okay, to illustrate this, we came up with this story, which is a kind of modification of something that's true.
Yes,
Actually, you will find.
You can get this all on the internet.
Not exactly like this, but sort of like this.
Special report. Was the moon landing a hoax? In 1969, NASA announced that it had put a man on the moon. In the years since, the Apollo moon landings have held a special place in American history, and until recently, nobody has doubted its validity. However, there is a growing wealth of evidence throwing doubt on whether man went to the moon at all. Was it all a hoax? You decide. It started when veteran photograph analyzer Allen began to question whether it was possible to land on the moon. I found we couldn't have done it, he says. The technology just wasn't there in 1969. Computers were merely glorified calculators. Allen says he has found many reasons why we couldn't have landed on the moon. Things like the impenetrable Van Allen belt and meteors make a moon mission impossible. But what about the pictures of astronauts on the moon, you say? Allen and his team studied the Apollo photographs and concluded there are literally tons of problems. Our discovery suggests these pictures were actually taken in a Hollywood studio. For example, look at the picture on the left. Where are the stars? See here, you can't see any stars. On the moon, where there isn't any atmosphere, you should see more stars than if you were on Earth. But you can't see a single star in the photo. See if you can see any stars in the next photographs. That one, there's no stars in this one. And this one, there's no stars. And no stars in that one. This isn't the only Apollo anomaly. Look closely at the shadows in this picture here. The shadow of the astronaut on the left is much smaller than the shadow of the astronaut on the right. See, that's shorter and that's longer. This would be impossible on the moon where the sun is the only source of light. Allen says there are two reasonable explanations for this. There were two floodlights lighting up the stage where the photos were taken, or two, there is a single floodlight very close to the fake astronauts somewhere over there. Now look at this one, see? This shadow here is much longer than that one. That doesn't seem to make sense. And here's another one. Look at the angle of the shadows in this photograph. This would seem to indicate that the light source is just to the left of the picture. Here we have, here you can see this line here, and we have the shadows pointing in that direction, while that shadow is pointing in that direction. It would mean that it would be like a light over here. Allen finds this photo the most convincing. Look carefully at the lower left corner right here. Did you see the C someone drew on the rock? This probably meant the rock went in a certain place on the stage. They just forgot to turn it upside down. Another question Allen asks is, how is it possible they took so many pictures? The average temperature on the moon during the day ranges from 260 to 280. How did the film and the camera survive? At that temperature, photographic film would melt. Why did NASA fake the moon landings, Allen says? Allen says the answer is simple. We were in the Cold War with Russia, and we wanted to show the world that we were better no matter what the costs. The end.
Okay, did this news report convince you? We were trying to convince you. Very hard. Was this good science? The things that were described in this report, was it good science?
It appeared to be good science.
It appeared to be good, at least science. It was some science. This report showed how it's possible landings were a hoax. And the reasons it gave were maybe you couldn't see the stars because they were all faked stars, or they forgot to put them in. Maybe there was a C on the rock because it was a stage prop. That's why. Maybe the film would have melted if it was really taken to the moon. And they hadn't thought of that. So it's possible we didn't land on the moon, right? Is it possible we didn't land on the moon? It's possible. It's possible they faked it all. But remember, possibly doesn't make probably. There's lots and lots of evidence that we did land on the moon. You have to think of it like a balance scale. You have evidence on one side, and you have evidence on the other side. Which side is heavier? Okay? Evidence we did land on the moon include things like all the photos and videos. Those are actually evidence that we did land on the moon. There may be some problems with some of them, but generally speaking, they're all very strong evidence in favor that we did. Moon rocks. Scientists have moon rocks today that they can study physically, that aren't like anything else on Earth. Thousands of scientists who worked on the project say it wasn't a fake. And you, of course, have the astronauts who were eyewitnesses. And NASA has explained all the anomalies in the photographs. Okay?
You can actually go to their website, and they have lists of all these things, because there's a lot of websites out there that have these photographs and show how they look to be faked. There's a lot of people that believe it. So NASA went and showed how all these things that they've done, these that are on these websites, are all false.
So we want you to say about this moon report.
Whoa, dude, you got serious logic issues, dude.
Some people have trouble seeing the difference between a possibility and a probability. And they need to learn to exercise how to do that, see the difference. Okay, we're going to talk about some serious tools for thinking scientifically. When you're trying to be a scientist, how do you think? What are some tools we can use to think this way? Okay, which problem would you like to solve? We have the kitchen stove isn't working. Farmer Gray's cow won't eat. It's like wasting away. It's starving. Will colloidal silver cure the common cold? And the family computer won't work. Which problem would you like to solve? Family computer. Number 3. We're going to do the farmer's cow problem. That's the one we did. This is the story of a very bad science project. Okay, Farmer Gray has a milk cow, and it won't eat. It's wasting away. Here's a picture of it up here. Poor cow. Very poor cow. Okay, so he thinks it could be bad hay. There's something wrong with the hay, but he doesn't want to replace all the hay. That would be really expensive to replace all his hay. Costs too much. So Farmer Brown down the road, he suspects a twisted stomach, and he suggests calling a vet. Okay. But Farmer Gray doesn't like calling vets because it's too expensive. And so he looks at the cow. It doesn't have any strange bulges in the stomach or anything like that, so he doesn't think it's a twisted stomach. Now, Farmer Judd down the road, he once fed peanut butter to a cow, and it got its appetite back. So Farmer Gray feeds 3 cans of Jiffy to his cow. 2 days later, cow dies. We want you to say about this science project.
Whoa, dude, you got serious logic issues, dude.
Now, if we were Farmer Gray, what's some thinking tools we could have used? Tools he didn't use. Here's some examples of things he could use. He could experiment. He could try feeding hay, some different hay, to his cow, just the one that's sick. He wouldn't have to buy all new hay. He could just feed some new hay to the cow. Okay, that's an experiment he could have done. He could have gotten advice. Vets know an awful lot about cows, and he could, at least by calling a vet, he could have gotten a second opinion about the issue or what's going on. He could research. He could read about twisted stomachs, which is called a displaced abimosum, because we had a cow that had that. And it doesn't necessarily produce any bulges or anything that you would necessarily see. And he had some assumptions. Because he was tight with money, he assumed calling the vet wasn't worth it, but he ended up losing the cow, which is like $2,000, so he ended up losing more money. The point here is science can help us if we use it. we need tools, like I was saying, science thinking tools that we can put in our science tool chest, pull out when we need them. Because you have science problems that happen all throughout our life, problems that science would help if we had the right tools that we could pull out and use them. Here are some tools, 5 of them. Observation, that's where you learn to carefully collect data. You keep notes. You learn to use measuring instruments like a microscope and things. Hypothesis, learning how to make a hypothesis, which is when you invent an idea or you explain a problem. Experimentation, that's where you test your hypothesis. You design an experiment, you use variables and controls, and we're going to talk about that in a minute. Analyze data, that's where you make a graph to kind of figure out what this data is trying to tell me. You try to verify your hypothesis. You question your assumptions behind what you were thinking. And also, very important, get advice. This is where you do some library research on other scientists that study the issue. And you ask experts, and you look at opposing viewpoints. These are 5 of the main scientific thinking tools that you can use. Now, if we have some scientific thinking tools, we can use them in science fairs, because we've been talking about projects and trying to be practical in this workshop and how to use these things. And kids can use these tools in science fairs. Okay, what's a way to motivate kids to do projects like science fair projects? We came up with different reasons. There's a lot of different reasons to motivate kids. What motivated you to do a project? These are some things I was not motivated by were things like catching up with brother. I wasn't very motivated with catching up with people. Fear about being stupid. These are some people are motivated by these things. They think it'd be good for them, like good exercise or something. I was motivated by winning. I like to win. Prize money, $50 to $100. Anything less wasn't important. I enjoyed building things for fun, like model rockets. That was one of my experiments. Other kids have a natural inquisitiveness. I think this is rare. My mom doesn't. A natural interest in a subject, for instance, horses or guns or something.
Yeah, like my sister, she couldn't care less about science things. But if she had a project that did something with horses and she liked horses, then she would like to do it.
Also, some kids like to be around people, so a survey project can be a motivation factor to get them around people, making some sort of survey. Basically, you need to find kids' natural motivations and find your own natural motivations. If you're trying to motivate yourself to do a project, what am I interested in to get myself to do this?
Want to help me make a poster? Sure, what's it for? It's a school contest. We're supposed to do traffic safety posters. The winner gets $5. Think of it, we'll be rich, and then there's the fame and glory. I tell you, this could be our ticket out of this 2-bit dump. Sounds good. What's our winning poster going to say? That's where you come in. Mom suggested the slogan, before you cross, look each way, you'll get safe home each day. Home safe each day. That's kind of catchy. Yeah, but I like my idea better. Be careful or be roadkill. I suppose that lends itself more to your particular brand of illustration. I hope I have enough cadmium red.
You can't expect people to be interested in the same things you are as a parent. Okay, here's a question. What makes a winning science project? What makes a project in a science fair that will tend to win? Here's some things we came up with. 1, having a creative idea. Scientific thinking, the scientific thinking skills that we're going to continue to talk about, and a clear presentation. First of all, creative idea, that means judges want creative experiments. They don't want volcano models. A volcano model is not an experiment of anything. You're not experimenting with anything. You're just making a model. And volcano models rarely win, or usually never win. They also don't like overused ideas that every year the same thing comes up, like putting teeth in Pepsi and watching them dissolve or something. Contemporary issues often win if you try to address a contemporary issue. Judges want to see you solving problems that exist today. Here's some examples I found on the web. This is from the Intel Science and Engineering Fair, International Science and Engineering Fair. Michelle, a 16-year-old from New York, saw the World Trade Center tragedy unfold at close range. She watched the search for survivors stretch out for days. She felt frustrated by the lack of technology to locate victims. I began to research current devices and found they all had faults, she said. If a building collapses, you could use my probe to locate victims. Okay, now, she probably didn't invent a probe that could actually be used, but she started in that direction. Renato lives in Lima, Peru, where many homes are without electricity. This 16-year-old applied the principles of mechanical engineering to turn an ordinary bicycle into a human-powered machine to perform a variety of tasks. Okay? He maybe didn't revolutionize the economy of Peru, but he was trying to address a contemporary problem that was around him at that time, and he was not totally being successful, but he was trying, and he made some headway. So basically, they had a simple idea that pointed the way to future research. Judges know if you cheat. So you need to be interested in your subject, and you need to have done the work on it yourself, because they can tell if you haven't done the work and your parents did it for you. Okay, number 2, scientific thinking, demonstrating that you know how to use scientific thinking. Simple projects can win if you use the tools of the scientific method. This means making sure you have an hypothesis. This is a hypothesis, a tentative answer to a question. You have a problem, a question, and you come up with, possibly this is true, and you're going to test it. So but you make sure you have a limited question, a limited hypothesis, not something complex. You do an experiment. This is where you design an experiment that gives you a clear yes or no answer. In other words, you have a hypothesis, you have create an experiment to prove it yes, is it true, or no, not something that's going to be vague. There's more about these things in your handout. As an example, this is my 1992 project, The Effects of Extra Low Frequency Electromagnetic Waves on Plant Germination and Growth.
That's a mouthful.
It's also helpful if you have a very complicated title for your... Here's my experiment, the control up here, and the experiment down here. And then I have an electromagnet underneath. These are bean plants in trays, and they're growing. This is artificial lighting. And the situation in both of these is identical, except for the fact that in the experiment, you have an electromagnet underneath it that's attached to regular household current. That's why it's called extra low frequency electromagnetic waves. And so it's an electromagnet that's fluctuating at 60 hertz, the same as like all electricity around us is. This is what it might look like, the electromagnetic lines of force. I drew this for the judge to demonstrate.
Impressive.
Yeah, impressive. Okay, February 9th, 1992. Here you have the beans are starting to germinate, experiment, control, basically the same. There's no real difference between the two. Okay, February 12th, you have some difference. You notice they're kind of germinating over here, and they're germinating all over in the experiment, or in the control. Okay, and then on February 14th, you have a lot of difference here. The electromagnet is right here, and they're not germinating right over top of the electromagnet. Here's my display at the science fair. I'm in a bad mood, as you can tell. This is the electromagnet here. This is my journal. This is photographs in the display. Okay, in my project, I did have a control. As you notice, I had an experiment and a control. My experiment was simple. I was experimenting with just one thing, bean plants and the presence or the absence of the electromagnet. However, I did not collect very much data. That was a problem that I realized afterwards. That I only did this experiment once. It could have been a fluke, the reason why all the plants over top of the electromagnet didn't grow, because it could have been that the water, when I would water them, would stand there. And so, there's different things like that. So you need, when you do experiments like this, to do it over and over again, kind of change a little things a little bit to kind of demonstrate that it's not just a fluke the one time you did it. But I didn't have time because I came up with my idea too late and stuff. Okay, observing is another tool of scientific method. This is where you keep a journal, like you saw, keep a journal of everything you do, daily, whatever. You take photos. They like photos to see that you're demonstrating all the processes you went through. learn to use measuring instruments. You learn to measure the height of the plants. That was easy. Analyzing data. This is where you take your data and you create a graph, like I did on my board, and you try to be aware of your assumptions. Like I told the judge that I realized that my experiment had a problem, that I didn't run it more than one time. That was a problem with it. Being aware of that assumption, that problem. Did your experiment verify your hypothesis? And how does this project help people? They'd like to know that. And also getting advice. This is an important part. Do research at a university library on your subject. You go to a university library, you look up whatever low frequency electromagnetic waves, which was what I was looking up. I looked up research on the subject. At that time in '92, it was kind of uncertain about whether it actually was causing cancer or whatever. And since then, they've demonstrated it wasn't a problem.
So your experiment was totally fruitless.
Whatever. Also, talk to a scientist in your field. That was very helpful. I talked to a guy who was working in a lab, and he helped me test my electromagnet to see how powerful it was. Okay, third thing is you need a clear presentation. You need to wake up the judge, because to do that, you need a demonstration that's short, simple, smart, and simple. And it's because you're competing against a lot of different projects. You need to stand out as being that way.
Okay, let's wrap this workshop up here. Okay, our refreshing close. Cool breeze blows from the mountains. Any questions?